The second part of the lecture is going to focus on terminology. This terminology will be used to describe the images of the planar sets on the complex plane. As we stated, the modulus of some complex number minus the center is less than E or epsilon, which is also our radius. And in this case, we are going to refer to the radius as the neighborhood. So E is a circular neighborhood, and it can be described as the set of all points of a given center in the complex plane. If we go ahead and sketch example 1, we see that the center z sub 0 is 0, 1, the neighborhood E equals 1, and that it's an open circle. Here we can use the terminology open disk or an open set. And again, remember that a set are points of a given center in the complex plane. To be able to describe this image properly, we are going to say that the neighborhood consists of all points Z lying inside and not on the circle. So the set is centered at Z sub 0, which is 0i, with a positive neighborhood, which equals 1. And the planar set is an open set or disk. Then we're going to look at the center and how we can describe the center. Z sub 0 is an interior point if it lies in the set and if there is some circular neighborhood of Z sub 0 that is completely contained in set. And I will break that down for you. Go ahead and read that again. And I will go ahead and break down the definition of an interior point. So Z sub 0 has two conditions to be an interior point. The center must lie inside the set, and there must be some circular neighborhood, or in other words, a smaller radius than E, around the center that is completely contained in the set. So I'm going to blow up the example 1, the image of the example 1. So as you can see, this is 1, negative 1, and this is I, and this is 2I. So we know that our center is 0i with epsilon or E neighborhood of 1. So it contains all of the points inside this circle. And again, let's not forget to make this dashed or dotted. And if we choose another epsilon, I named it E sub 2 to equal 1/2. Well, 1/2 is less than 1. So right there is a smaller radius than E. And it is completely contained in the set. The original set are all the points inside the circle, but not on the circle. And this smaller epsilon is contained completely within that set. So hopefully you have a better understanding. And a question here would be, what kind of inequality function of a planar set would make C sub 0 not an interior point? So again, what kind of inequality would make the center not be an interior point? And remember, there's two qualifications for Z sub 0 to be an interior point. And lastly, I have a quick example that combines everything together. We're going to sketch the set of all points that satisfy the inequality and describe the neighborhood. So again, you are given a complex variables, z minus 1 plus I less than 3. First step is what we know. And again, we know that z equals x plus iy, and we use substitution. This note here is, can you recognize the center and the radius just by looking at the given function? You can consider that a shortcut. If you can't, that's okay. If you can, I still encourage you to be able to work through the whole process. That way you can verify if your center is correct and your radius. We use substitution, plugged in x plus iy minus 1 plus I. We're still keeping that inequality, less than 3. And now we combine our real and our imaginary. Combine or group, I use different language, whatever is easiest for you to understand. So here we combined x minus 1 to be a real, and iy plus I, we factored out the I, and y plus 1 is in the inside. For number 3, we apply the modulus formula and continue to keep the inequality. Again, we're going to square both sides. And we are back to our circle formula. And again, don't forget that you can describe or sketch in whatever order is easiest for you. To describe the neighborhood of C sub 0, we know that it's an open circle, or as the vocabulary is open disk, of the Z sub 0, which is 1, negative I, with a circular neighborhood of 3. And when we sketch, we have our center, and our E is 3. And a quick question for thought would be, what are possible exterior and interior points? Hopefully you recognize that Z sub 0 is an interior point. And hopefully you can think of an exterior point, which would obviously not be in the set. And that is all.